Welcome back, everybody, to another live stream. And we've got a super interesting one today. We're going to talk with Ian from Ignite Components about this whole concept of generative design. And basically, from my English major understanding, it's where you let the computer do a mass of the design work, setting some parameters, and the human goes in and cleans it up, as opposed to, let's say, traditional design where the engineer would come up with something and have the computer do analysis afterwards. So it's kind of a flip-flop in some ways. Like Skynet is designing your bike or your component. But before we get to Ian, I do want to say, check out the sticker shop. We still have a bunch of these stickers. Behind mountains are more mountains. One of my favorite sayings for not only cycling, but also life. And we've also got a bunch of these fun Party Pace retro stickers. Yes, at the end of the day, I'm just a sticker salesman with a YouTube channel. With that said, let's welcome Ian to the live stream. How's it going, Ian?
How's it going?
Cool. So before we jump into the whole generative design thing, let's learn a little bit more about Ignite. When did you start the company, or actually, what was your background, and when did you start the company?
My background is as a mechanical engineer. Been doing it. I know I might look a little young, but I've been doing mechanical engineering for over 20 years. Motorsport, motorcycles, bicycles, that stuff for quite a while. I've been riding my own components for about a decade in various bits and pieces, cranks, headsets, bottom brackets, pedals, brake levers, all that good stuff. And then so when I turned 40, my wife said, "Okay, buddy, you're starting to get up there. You got to start scratching some of these itches off. Otherwise, they're never going to take place." So the timing just worked out. Supply chain with the bike industry was bonkers, and I started Ignite for real probably about like February of last year.
Cool. So how's it been received? Is it doing well? Is it exceeded your expectations?
I don't think I've slept in like 6 months.
Okay.
What shows that it's going fantastic. I'm incredibly appreciative for all the customers who have put in orders. They're extremely patient because even though I make stuff here in-house, finishing and shipping and material procurement is just, I didn't expect it to be like this, to be 100%. It's fantastic. I love it to death. I like the dealing with customers that I have. The bike industry people are great. I've been to a couple of shows, plan on going a bunch more. It's been unreal.
Cool. How did you first enter the bike market? Were you direct to consumer, or did you work with shops first for early distribution?
Both. So a couple of shops real early on expressed interest, but it's been a healthy mix of both, right? A lot of it is wholesale, a lot of it is direct to customer. It's every month is different. I would say. Yeah, it's unpredictable.
Yeah. Cool. Well, I'm going to bring up your site for people that are on the live stream, just so you can see what the components look like. One thing that really struck me is how colorful they are. Was that like intentional, or was that just like you were responding to demand?
There's a couple of reasons for that, right? So I grew up riding BMX and racing mountain bikes back in the 90s, the heyday of like the incredibly fragile CNC components that were anodized incredibly rad colors. So like what you have up on the screen right there, like I bet you most of the viewers who are around in the 90s are screaming Kuka right now. And yeah, I would pick up Dirt Rag or Mountain Bike Action every single month when I worked at the bike shop as a 14 and 15-year-old and just like drool over all of the cool turquoise and purple components. So I knew when I started a company that I needed to have it represent kind of some of my values and kind of some of my background. And, anodized turquoise and purple and splatter from the 90s just had to be part of that. And it seems like most of the direct to customer stuff that I've been doing has been custom, and most of the wholesale stuff is kind of the solid colors.
Right. So they're playing it a little bit safer.
They're playing it a little bit safer. It's also interesting, like the Catalyst, the mountain bikes that you have up on the screen, that sees way more custom fun than the Infernos, which are the road and gravel crowd.
Oh, interesting. Yeah.
They play it a little bit more conservatively. Lots of black, lots of silver, maybe a little bit of pop in color with the extractor caps, but most of the customization stuff has been on the mountain bike side.
Yeah. Yeah.
Yeah.
I just saw that Shimano threw people that wanted silver group sets a bone recently with the GRX.
With the GRX silver, and like half the internet hated it, and the other half is like, yes, finally. So
Yeah.
it's interesting. You never know how things are going to be received, and there's always people who are going to be counter to whatever you thought.
Yeah, I think they were thinking, oh no, we're losing the hipster crowd. We got to get out some silver cranks.
Get out the silver cranks, which actually looks pretty cool. It's kind of got like a swoopy shape to it with the integrated 4-bolt.
Yeah.
Not bad.
Yeah, cool. Well, let's talk about this this idea of generative design. I tried to give a stab at a definition. Like, how would you explain it to an English major?
I think I'd explain it to anyone very similarly to how you did, right? So traditionally engineering, and this has evolved through the years, just like everything in engineering, it's like someone comes up with an idea, that light bulb moment, they sketch it out on the back of the proverbial napkin. And recently, it's like most people will rush for their CAD software and start drawing something up or do some calculations. And then as soon as they had what they thought was kind of the final iteration, or at least a workable iteration, they'd have it prototyped. And recently that kind of looks like 3D printing. And then you test it and you see where it fails, and you kind of grow your knowledge base. Like, hey, when this twists here, I need to add some material over here. I can remove it here. And that's been the engineering process, forever. Generative design is a fantastic tool to add to that toolbox. I personally would never rely on it solely to give me an output and take it to the bank. But it certainly can open your mind up to some of the possibilities and material shapings and kind of cross sections that you might not normally think when you kind of have the engineering blinders on of this is how I think it should be done. It kind of will politely let you know that some of the assumptions that you have are way off base. So it's neat. So to talk about it a little more, you kind of have to, it's the old adage of garbage in, garbage out. So you still have to know what loads the component is going to see. You have to know how to constrain it and say, hey, out, but let's just talk about cranks. Out by the pedal end, you still have to have that 9/16 20 thread out there. You still have to have the pedal spindle be a certain length and then apply a certain load. And what I do is I normally look at the testing standards that are out there in the world. So like the ISO or EN standard is 1800 newtons, like 2 inches out from the end of the crank arm, and which translates to like 818 pounds, and you just keep loading it. Mm-hmm. So you have to know where to put that and how to define it. You have to know how to define back by the spindle and say that that's fixed. And then you also need to kind of model the bike accurately to say, well, the material can't go over where the chainstay would be, and the material can't go out where someone's ankle has to be. So you kind of have to really narrowly define to the computer what you need it to kind of work with. So you can kind of define like a tube, and you can say, hey, you can do anything you want inside this tube, but if you step outside that, this person's breaking their ankle, or you're going to bash the chainstay, or you're not going to be able to fit the chain rings in there. And then you kind of let it go wild. There's a couple of parameters that you can select for, like what your priorities are. Mm-hmm. Like, do I want to save cost? Do I want to make it stiff? Do I want to use a certain material? There's a couple other parameters depending on the software that you're using that you say, hey, here's this geometric shape that I'm thinking you can kind of play with. And this is kind of what I'm looking for on the output side. And then you just let it run nuts. It'll crunch numbers like only computers do. And it will give you a couple different versions of what it thinks is optimized. And certain ones you'll say, that's the ugliest thing I've ever seen. I'm never going to make that. And other ones you're like, yeah, that's pretty cool. But I've never done it and knew what it was going to spit out, right? Mm. Like even with 20 plus years of engineering and motorsport and motorcycles and stuff, it will always give me a result or two that kind of gets your head scratching. And I think that's why I think it's so powerful is I wouldn't ever just take it and say like, yeah, this is my product. The stuff go through testing and everything else, but it definitely, it gives you that things that make you go, right? Which is fantastic. It's just another tool in our toolbox.
Yeah. So from what I understand, like some of the shapes it comes up with, they tend to be a little bit more like organic, almost
Yeah.
like alien looking, like, so not, like something like a human might just go, this is how I would do it. It just takes a different approach.
Yeah, I've heard a lot of people, not necessarily with cranks to designs, but I've showed it to students and stuff like that who are learning engineering for the first time. A lot of them are put off by that kind of alien skeletal look. They say it looks too like raw or too visceral or too dirty, and they're put off by it. And I think there are a lot of people that think generative design just gives you that, and that's not always the case, but certainly it's interesting. I don't know who wrote the algorithm on the back end and what sort of inputs they have the AI kind of modeling after, but I think it was probably a lot of like large whales and trees and things like that, because a lot of the shapes end up looking very skeletal or very alien.
Yeah, a lot of Ridley Scott movies. Like
That's what most people say. Yes.
yeah. Um, so has it ever spit out something where you're, maybe we're kind of repulsed by it at first, but then we're like, oh, that actually makes sense, and there's no way I would have approached this problem from that end.
I can't say that I have. Not necessarily repulsed by it, because you always kind of have to look at things with an open mind, especially in engineering. If you fall into the trap of always doing things because that's the way they've always been done, you're not going to ever advance. You're always going to kind of remain stagnant. So I think it depends on the user's perspective. You have to be humble. You have to realize, like, there's no way in heck I know even 1% of all of the knowledge out there with engineering. So you kind of always have to take it as a learning opportunity and say, hey, this is a flawed piece of software. It's not going to ever be perfect, but it's going to at least open up some possibilities that I hadn't seen before. So I think if you have that perspective, it's still going to throw some junk at you, and you're going to be like, yeah, but it's interesting. It's cool.
Yeah. So the whole
Yeah.
idea is fairly new to me. Are there industries that have been more proactive in its use, and is
I think
bicycling more of a late adopter, or has it been in the industry for a while?
that's a really good question. I know from the research that I've done on it, it originally started in civil engineering and architecture back in the 70s. I'd love to see what it was spitting out that I haven't been able to find anything, but I'm imagining like 70s, like, whew, like the computing power would not have been what it is today. So to get all these crazy shapes, it was probably very narrowly defined, right? Like probably calculating how a floor plan should be laid out in a house given certain inputs of how the people moved throughout the day, that sort of stuff, what we call pattern living, I guess.
Mm-hmm.
Yeah, and it's evolved from there. It really kind of has gone hand in hand once 3D printing started taking off, right?
Hmm.
Because I think people had the ability to take whatever it gave and just 3D print it, and it looks amazing, right? Like I've seen desk lamps. I was at a facility for a piece of software that actually does generative design. I'm not going to name them, but they had an office desk in the atrium, and the office desk had a 3D printed generative design kind of lattice structure that held up this whole glass countertop, and it looked amazing. It was really, really cool. But previous to 3D printing, like how would that have taken place? And even with like super advanced 5 and more axis CNC machine some of this stuff is probably impossible most of the time, or definitely not cost feasible. So 3D printing, especially with the newer, titanium stainless sort of printers, I think we're going to see it more often, or at least used as an aspect of the engineering process more and more. The bike industry, we've certainly seen on, some of the news outlets and stuff, stems and cranks and bikes with these helix down tubes and stuff like that. We're going to see more and more of it. I think it's going to become more refined and less organic looking. It'll be more elegant and I think more streamlined to what our eye is used to seeing.
Yeah. So you mentioned that it's kind of a tool in your toolkit. At which part of the process do you use generative design?
Fantastic question. I think it depends on the component, and I think it depends on how much previous knowledge I bring into it. And I'm just talking from my personal whether it's bikes or cars or motorcycles or whatever. So normally it does start out with that idea, doing a little bit of research to see what's already been done. Maybe buying some other products and testing them and see where weaknesses are with other products. I think it makes a super informed decision when you actually go to put pen to paper. And then sometimes then I will start doing some generative design with some of the constraints that I think exist, just to kind of open up my mind. And then I'll kind of go down a design wormhole and kind of take it and flush it out to where I think it should be. And then sometimes, not all the time, but sometimes I will then take that model that I think is pretty cool, and then I will put it back in the generative design and use that as the base or the foundational model to see where it thinks there's flaws with it. And it's hard because a set of cranks, for example, there's so many different things. Like really, it's fixed on the spindle end, and you got the pedal end. But depending on where that crank is oriented, like here's a crank arm, right? Depending on where this is oriented, when this is like horizontal to the ground and this has got a load on it, it's in torsion. But when you get down here to the bottom and you have that pedal load on it, it's bending basically like a vertical diving board. So the load and how it translates through this material is different depending on its orientation and cycles and everything else. So it's hard to, or impossible, at least with my own knowledge, to get it to output for all of those different things. So you might have like a 90-degree model and a 45 and a 30 and a 0. And you kind of, the way that I do it is I'll do a generative design for all those, stack them all on top of each other, different colors, and do cross sections and see what are the commonalities, what are some areas where it needs material in all of them. And I find, to go back to your first question, has it ever given me a result that I've scratched my head on? And the answer is when I do things like I'm just describing, where you're stacking all these models and you're looking at kind of the synthesis of all of it, where's common ground, that has opened my eyes to some different design aspects that I don't think I would have seen otherwise. So yeah, it's pretty cool.
Cool. So I asked you this before we started, but assuming two engineers are using the same bit of software and they input the same kind of constraints on the design, will the two machines essentially come up with the same design?
It should.
It should.
It should. I've done this a couple of times with students in the past just to demonstrate it. They'll get like a dummy model and they'll run it just to kind of see how it goes, because it's a very complex process where you have to go step by step by step to define all the different parameters and aspects and constraints. And yeah, it should give the same, as long as you're using the same software and the same constraints and inputs. Yeah, it should give you the same expected outputs every time.
Right. Let's see. All right. So we've got 65 people in the chat. If you guys have any questions about generative design or Ignite components, feel free to ask in the comment section. So we've seen, or you've applied generative design to components. What if you applied it to an entire bike? Do you have any kind of notion of what it would come up with?
It depends. Yeah, that's fantastic. And I think it would be cool. Let's follow back up on this. Maybe I'll do this in one of the spare moments I have, like 15 years from now, and then I'll get back to you and I'll tell you what it comes up with. No, like all kidding aside, I really think it would be pretty neat, because you have the contact points of the axles, and there's loads going through those in all different directions and gyroscopic effects, and then you have the rider and planing and everything. So that is where generative design, I think, is pretty clutch, right? For an engineer to figure out every aspect of all of these loads, the calculations I would never even dream of how many notebooks you would need to fill or how many lifetimes it would take to calculate all that. And that's what computers are fantastic at. So if you could just say that those are the geometric points where loads are coming in, and you could specify all those different loads, you can just sit there and just crunch those numbers and give you something pretty neat. I still think the triple triangle is probably the simplest, most elegant solution to that. It's been around for well over 100 years, and it's designed that way for a reason. Triangles are the strongest, when you have the loads oriented like that. But it would be interesting to see for a standard rigid bicycle, like your typical gravel or a rigid mountain bike, what it would come up with and what those tubing junctures would look like, you know.
Do you think you'd have to do a process similar to the cranks where you build different models depending on different phases of the pedal stroke to anticipate loads and then find commonalities, or would it be simpler than that? Or is there...
Yeah, there's more inputs. So on a crank, theoretically, you could just apply a load in a couple of different orientations about that. So it would theoretically represent where that crank is at any phase in the pedal stroke. It would be harder for a frame, and because you'd have to not have, unless you already had the fork designed, you could import that in and say, hey, this is the fork that I'm going to use. But all those loads would be put through the head tube and everything else. But it would certainly be complex to define it in a way that I think you'd get a meaningful result.
All right. So when you hit the do your generative design thing, like how long does it take? Is it like a matter of minutes, hours, or?
It depends on the software, right?
Okay.
And for certain things, I won't ever use generative design, but on something as complex as a chain ring or a set of cranks or a stem or something like that, it's at least interesting, even if I just take it with a grain of salt, just to kind of see what it comes up with, just as I would go online and research what has been previously done and, who are all the other component manufacturers doing this and why did they do it that way? I think it's, I don't know.
So typically for the crank, like,
Yep.
after you input the parameters, how long are you waiting for it to spit out something?
It depends on the software, right?
Okay.
Like everyone thinks that Fusion 360, which is an Autodesk product, that's what most people think of when they think. But NX, which is Siemens, has it. PTC, which is Pro or Creo, has it. SolidWorks with the topology. All of these different softwares have it, and they're all have pluses and minuses. Typically, if I did like a crank design in any one of these, it would give me 6 to 24 results, or I'd narrow it to that range. And it might take anywhere from a minute or two up to, say, I don't know, half hour.
Okay.
Is pretty quick.
Right.
Like when you consider all of the computational power that it's doing, and that, let's just say Fusion, for example, is doing it cloud-based. It's pretty phenomenal that you can get that resolution or that output in that short amount of time.
Yeah. So when you're designing, I'm assuming the software has like material profiles.
Yeah.
So it can all the different.
I would say it has, most of these softwares have a large library of all of the commonly used materials. But if you need to define something specific, like on the cranks, there is no profile because I use primarily 7075 T651, and they just had 7075 like annealed. So I actually had to go in and create a new material with all of like modular elasticity and hooks, all that stuff in there to define a material for myself of materials that I knew from testing, tensile testing and fatigue testing, what the properties of that material were to get a more accurate result. But if you just wanted, 6061 T6, like, yeah, it's got it in there, or most of the commonly used materials it has. Most of these softwares do.
So we've been talking about generative design in terms of loads. Can it be used for like aerodynamic optimizations, or is that beyond its purview?
Ooh. You know what? I'm not gonna answer that because I don't know the answer to that. So CFD, which is computational fluid dynamics, that is like so when you're doing a structural analysis on something, let's just say this pencil, and let's just say that I fixed it here and I applied a load to it. Before generative design, there was stuff called FEA, and it's still used. It's just another tool. I'm sorry I didn't mention it before, and that's finite element analysis, and that will basically show you where the material is stressed and where it's not stressed. And that is what generative design is using. And then once it sees that it's stressed or non-stressed, instead of a human being looking at the result of it and being like, oh, okay, here's red and here's blue, I'm going to remove material where it's blue and add it where it's red. Generative design will just do that hundreds, thousands, millions of times until it optimizes the shape. So it's basically just acting as the human, looking at the results from FEA
Hmm.
to say, okay, this is where it's stressed out. I'm going to go back into my model and now mess with it. So that's really all it's doing more than what a human would do. You
Right.
could certainly design the set of cranks that I did without generative very easily. You would just have to take, hundreds of hours in order to run it through that. So CFD is that analysis, but on the fluid side, to see
Hmm.
how fluid, whether it's air or any other fluid, flows around or through an object. So that's a fantastic question. I would have to think that it exists, and if it doesn't exist, it will exist very shortly, where your object can change depending on the way that the fluid is flowing over. That's really cool. I'm going to actually Google that once we're done here.
Yeah. Cool. Well, let's talk about. Do you have any of the cranks in your hand?
Yeah.
Yeah.
So what do you want to see here?
Well, for some people, for people that aren't familiar, like what are the standards? Like
This
is a spider proprietary? All that stuff.
Yeah, so this wacky one is the first one that came out, and this is after maybe. So this is the production version. I certainly rode many ones that looked far different from this for up to a decade before this one came out. But this is a mountain bike crank. It's got a pretty narrow Q. It's like 168, and it's got just a standard 3-bolt here.
Hmm.
Obviously, pedal thread standard. That's about it for that. 70, 75. It weighs roughly like 520 grams for a set. Comes in lengths from like 150 to 190. I think I actually did a set of 210s for someone.
Oh,
Can't imagine the pedal strikes there, but someone wanted 210s. So this is a pretty funky one. I guess when you're talking about generative, this is the one that I actually use to kind of get some of the shaping in through here. It's kind of a little weird looking there. Some people say it looks like a cobra.
Yeah.
It's kind of interesting there. And then, so that's the mountain bike one. There's a new version of that's called the Catalyst. There's a new version of that coming out in about a month that's lighter, stronger, stiffer, which most people are like, well, how the heck does that happen? It does. So testing always yields results. And then the Inferno, which is kind of like a pretty traditional looking rotor gravel crank. Sorry, the lighting's not that great here, but this again, 150 to 190 in lengths. Pretty cool. I'm really proud of this with machining. The tool paths and the lines on this are just, in my opinion, I probably took like about 100 hours to get them like perfectly dialed in. So this one I'm pretty proud of. That's a road and gravel crank. Q on this is like 148-ish.
Okay.
Yeah. It comes in 3-bolt or 8-bolt.
And the cranks are they 1x only, or can you set them up 2x?
You can set them up 2x. So I do spiders. I'll just hold the spider up here. Spider is 2x spacing. So you can run inner, outer. I'll also do different offsets depending on chain lines. There's some guys running like fixies with 2.2s in the back, and they'll need like a weird chain line there. So spiders in both 3-bolt and 8-bolt. Let's see, 104, 110, 110, 74, 130, 130, 74, 144, and anything weird too. And then triples too. So that's a triple. Cool. So it's a 110, 74 spacing for, I do them for like 8, 9, 10, and then 11, 12 speed for offsets there. And spiders like that too.
So that's super flexible. I mean, I feel like outside of, the wide industry's variable bolt circle, you cover a lot of bases.
Try to. I guess that's the beauty of being small is you can kind of do some weird stuff. As long as you have time for it.
Yeah. I'm going to bring up your site again. So I don't know if people can, so there's these kind of topo looking design, or so these are tool paths, right?
Yep.
So that's kind of a neat way to just work in the actual tool path, so it adds to the aesthetic.
I try, yeah. So there's form and function, and I'm not gonna be all preachy and stuff, but I want stuff to look cool, or at least to my eye. And so I try and blend as much kind of like actual like smooth machining, like surfacing with contrast that with some of these tool paths that, I'll either let the CAM software dictate, or sometimes I'll actually go in there and sketch like topo lines or whatever else to get it to actually follow it, because I have like a particular aesthetic that I want it to achieve. And that's like the devil's in the details stuff. Some of those tool paths, I will sit there and tweak for like dozens, if not hundreds of hours, just to kind of achieve a certain look.
Right. So are you at this point pretty much a one person operation in terms of the manufacturing?
Yeah. So right now I'm doing kind of all of it. Like it's quiet in here right now, but 10 feet to my right is where the magic happens. And that's sleeping right now for Sunday night is a rare thing, right? Normally, depending on what I'm making, like let's just say a set of cranks, for example, I'll have maybe 12 cranks in the machine at a time. It might take, I'll just run it real super slow because I'm not around. And for 6 hours and 24 minutes, it does its thing. I come back, load it back up, and rinse and repeat, 2 or 3 shifts of that a day. But yeah, one person shop, which is manageable, but the supply chain issues are real. Like just sourcing stuff is insane.
Right. How many operations does a crank have to go through? Do you have to like turn it on its axis, or do you have a CNC machine that can attack it from different sides?
This is a piece of, I'll actually show you. So this is 7075 T651. This is Messina aluminum from the USA. So this is good stuff. This is expensive. This is how it will go into the machine. And I would bring over a big pallet, but they weigh about 85 pounds each because they hold 6 cranks across. And they're these big, it's basically like a big dinner plate. And it will just have these just lined up across it, bolted down. It will come in from the top and machine the whole thing. And let's just say for a set of Infernos, like 20 minutes later, you'll get the back half completely finished. And it will just leave this little bit of holding material right here. I think this is only like 90 thousandths on this. So it'll machine the whole backside. Then this gets flipped into another fixture and it clamps on it here and here. And then it will just machine the whole top side. And on an Inferno, that takes maybe 12 minutes, I would say. And then that would be, so 2 operations for a set of cranks. Something like a preload adjuster, one of these it's super simple, but this will be 3 or 4 operations depending on the preload adjuster I'm making.
And do you have to rotate it and put it back into the new holding fixtures, or?
For this preload adjuster, it goes in like as a Frisbee, kind of sitting here, and then it flips upside down and machines there, and then it flips on the side to do all of this, the drilling, and then, I'm not vain, but it does have Ignite logo on the top. So it does all that, and so this is only 3, but some of them might be 4. And if it's any more complex than that, then I'll use a 4th axis, which can actually spin it while it's doing it to do. So yeah, fun stuff.
Yeah. So then so you get the cranks out, you have to send it away to finishing, and then do you do the fulfillment when it comes back, or?
So 2 feet to like right off camera here is a whole workbench and a couple of toolboxes underneath of it. And the toolboxes are like big rolling toolboxes that you would normally have with tools. And I have cranks in various stages and parts in various stages and bins and everything else. So yeah, I'll do procurement as soon as stuff comes back from finishing, whether it's Cerakoting or anodizing from a number of different finishers. I'll normally do like one last QC on it, make sure everything is within spec before I actually assemble them. I'll assemble the cranks. I have my order sheet up there, wrap everything, make sure all the labels are generated and ship it out. Normally within 24 hours of getting it back from finishing, which has really been, I have like amazing finishers that I work with. I mean, you'll see all those crazy colors and stuff, but people who are really good are really swamped right now, like unbelievably swamped. What normally would take 2 or 3 weeks is sometimes 3, 4, 5, 6, 8 months.
Oh dang!
Which is it's just how it is. So, yep.
So where are you in your production? Are you fulfilling orders already made, or are you taking in new orders?
All of the above.
Yeah.
You have to be when you're a 1-person shop. Like it's insanity. You'll wear 45 different hats in the same day. And yeah, it's been awesome. I'm not going to say anything negative about it, because this is a dream. It's absolutely incredible. Like when I was a little kid, I dreamed about making bike parts, and here I am, 35, 40 years later, and I'm doing it, and it's amazing. The people are cool. My customers will send me stories about how, like, hey, and let's face facts, like cranks, they're really cool, but they don't really significantly enhance the performance of your bike unless they break, right?
Right.
So when your crank breaks, you're not going to have a good day.
Yeah.
So, but people take a picture of their bike next to a thing, and a lot of it is look, and they'll say like, hey, these things just look amazing, and I get all sorts of comments, and I'm really proud that they're on my bike. That's, I had this person make the frame and this person build the wheels for me, and it just kind of sets it off as like that last piece. But a lot of the customer stories are kind of what makes it worth it, because you put in a 16-hour day, and you're shot, you're absolutely shot, and you'll check your email before you go to bed, which is probably not a good life habit, but I do it. And then someone will just send you a picture and be like, hey, I was up on top of the Monarch Crest today, and it was amazing, and here's a picture, and it's just like, their awesome bike, and they got this smile like that, and that's cool. I really like that.
Yeah. Cool. So
Yeah.
what are your next steps for Ignite? I mean, how long do you think you can maintain being just a one-person operation?
So that's a fantastic question, but it's a good question. Like and that would be a good problem to have.
Yeah.
Is as much as I'm doing all of this stuff, like it's cool because I can do orders of magnitude with just automation.
Mhm.
There are a lot of really smart people out there. If you look at like Austere Manufacturing, hopefully he's watching right now. Dude is a genius with how he gets his CNC machine to basically be an automated robot within the CNC machine to swap parts out. There's a lot of really cool things. There's a lot to learn, and I look forward to learning it to get my processes faster and more efficient, as well as kind of scale them up so I can keep this rocking and rolling. I have a lot of cool ideas for other products, bike-wise, and it's just a matter of finding the time to make it happen.
Right. Cool. We've still got people in the chat. If you guys have any questions for Ian, let's see. We'll dive in here with the people I have. So Rick asked earlier, how can you stress test such unique parts? So do you just run it through FEA, or do you you have a machine that kind of bashes around
Yeah,
things?
fatigue tester is really the right way to do it. So I'm in the process of, so that's another thing. I'm in the process of teaching myself like Raspberry Pi and everything else, because I'm building a fatigue tester that is not purely mechanical, right? So right now the fatigue tester is basically like a big electric motor with a eccentric cam on it with a valve springs, and when it deforms a certain load, I know what that load is on the cranks. It's a big, noisy, scary thing. But yeah, so the goal is to basically make something that I could bring to a trade show and just have run silently in the background. People are like, oh, what's that? And it's got a big digital readout with how many stress cycles it's been through.
Mm-hmm.
Just a piece of advice to anyone out there: try to not purchase anything that has not been tested or verified. So testing is kind of, it's the sanity check on all of the ideas that are up here, whether it's me or anyone else. So yeah, you have to stress test in the real world as well as like on a shaker rig or a fatigue tester to see how that thing's going to go. The standard for cranks, that one of the standards out there is the ISO standard. Like I said, there's two different ways they test it. They put this at 45 degrees. They thread a pedal spindle in there and they load it. And I'm sure all of you have seen this on YouTube. And they will sit there and they'll load it with 1,800 newtons, which is 818 pounds. And as long as it passes 50,000 cycles, it's past that. And then they move it to 30 degrees and do the same thing. So that's the ISO standard for crank testing. And I do my stuff to far surpass that before I kind of can sleep well at night.
Yeah.
Yeah.
So kind of related to that, it's kind of an interesting question. How do you plan for non-rider input loads like a rock strike? Is that beyond the purview of the mountain ISO
It's
testing
fantastic.
even?
It is beyond the impact testing is it's chaotic. Right, because think about it. There's no way to predict exactly how someone's crank is going to strike a rock every time. That's a fantastic question. You're bringing up like your food for thought in my head right now. Russ is saying, okay, you got to do the generatively designed frame. So I got that like stewing already. And now like I got other gears spinning up here. Like, okay, could I feasibly test for rock strike? It's weird because normally when you hit and you're just pedaling along and you have that rock strike, that would be pretty easy to simulate for or create some sort of test for. But we all know like when you actually hit a rock really bad, like the moment, you don't know what angle the bike is at and how it's loaded. I mean, 2 years ago, I had a tree go through my leg while I'm just riding along. So yeah, you can never really count for exactly what's going to take place there. But that doesn't mean I guess you couldn't try. So thank you for bringing that up.
Yeah. So what bike shops currently carry your cranks? Just if people want to buy them locally.
All over the place. What has happened recently, and I guess this is just because I've been wearing a little too many hats. I never actually formally like reached out to any bike shops or did any sort of distributor or salesperson whatsoever. It's basically been kind of that happened super organically. And it's like people would reach out, and I've had bike shops in Japan and Singapore and Germany, the US and Canada, and they'll reach out to me and they'll just say, hey, you know, I'm interested in carrying a couple of your cranks. Could I buy one or two just to test out and, you know, get wholesale pricing and then sell it on to their customers at full retail? So if there's a better way to do that, I'm all ears, because that's one side of the business that it's not that I'm not knowledgeable about. It's just something that has not, it's kind of been on the back burner, is growing the business through getting the word out.
Right. I think you're doing pretty good. I mean, you know, at least like perusing through the gram.
So you're trusting that algorithm.
Well, you know, I feel like I have a good sense of what's trending or what could pop off. So
yeah, awesome. Well, that's good. That's good feedback then.
Yeah, that's one of the reasons I wanted to reach out to you now before like
No,
before you get too big.
No, I don't. I hope that doesn't change me as a person.
Right.
So it will just mean that my garage or my workshop is a lot noisier, but I hope to still be me.
Yeah. So going into business, being a one-man operation, does it give you a new perspective on what it's like for other brands like Paul or White?
Yeah. A tremendous amount of respect. Knowing what I know now and knowing what I still have yet to know, it's humbling to say the least that some of these companies have not only made it, but they have cult status 30 and 40 years later. Is just, it's incredible. It's awesome.
Yeah. Where do you see your cranks in the marketplace? Like, who is your ideal customer, or who's buying your cranks now?
I would say that the person who's buying my cranks, if I could stereotype, and I'm not one to normally do that, is normally someone who values kind of that like artisan handcrafted, even though obviously I have a CNC machine, a nice high-end CNC machine creating the products. There are like hundreds of hours that go into the design and the aesthetics and the QC and just making sure that the lines just flow kind of right visually. The person who is an Ignite customer kind of appreciates that and wants something different than what's already out there, right? And then there are a lot of people that functionality wise, they'll need something that's a weird length, right? Like I had a bike fitter who reached out and they're like, I'm dealing with someone right now has a vast leg length discrepancy and they need a 135 on the non-drive side and a 160 on the drive side. Can you accommodate that? And I'm like, yeah, I can do that. So, and that's fantastic. That's more rewarding, I have to say, than the person who sends me the picture from the top of, you know, some amazing mountain. That's cool to be part of that. But to unlock riding for someone who has not been able to ride previously or has been riding with a 2x4 taped to the bottom of their shoe, that's pretty awesome. That's that gives you the warm and fuzzies inside for quite a while. And I have the warm and fuzzies right now recalling that, and that was 6 months ago. So
Cool.
yeah, so I would say that I can't stereotype an Ignite customer. It runs the gamut. There's a whole bunch of different people who choose these for all different reasons, and I just have to say I'm appreciative for all of them.
Yeah. So Rick asks, Ian, would you consider consulting for other manufacturing? I know we talked about this a little bit, but you actually did some work with the folks with James over at Analog, right?
Yeah, so just as a consulting thing, all the ideas are original in his, but a lot of times if you don't have access to equipment or you haven't done engineering before, and he's not the only one, there's been a lot of other companies within the industry that have consulted with me. Some of the larger companies too. It's just someone who's small, who's outside of the box. I think I talked about before the engineering blinders. It's pretty common practice in engineering, not just bike industry, to kind of get a second opinion because they bring fresh ideas in, and I think that's how growth takes place. So yeah, I've been consulting with a lot of other companies in the bike industry. So
cool. Sweet. Well, I think I'm gonna wrap it up here. It's been such an awesome conversation. So thank you everyone who's still in the chat. If you haven't already, definitely check out the website. It's ignitecomponents.com. Yeah, I think super lightning conversation for me as a literature major.
Thank you. And I'll get back to you, Russ, about the generatively designed frame. I'll play with that in my spare time. But thank you so much for reaching out and setting this up. And like I said before we got on here, I've been a longtime follower. Back when I think you were one of the only guys on YouTube talking about bike packing and fly fishing and all that stuff. So
yeah,
thank you so much, and continue doing what you're doing.
Cool. All right. Well, thanks everyone. Again, if you haven't already, be sure to support the channel. We still have a bunch of stickers. Our party pace one. We have caps coming soon, and that's how we support all this. We have no major sponsors, and it's almost nearly 100% viewer supported. With all that, keep the supple side down.